next presentation. Next presentation from the Bestech. I will invite Jeremy to give the presentation.
Good afternoon, everybody.
Okay. Yeah.
Can you hear me?
Yeah.
Good stuff. Good afternoon, everybody. My name is Jeremy Bryceson. I'm one of the product specialists for Bestech. One of my areas of responsibility is vibration sensors, amongst other things, data acquisition. So we're going to talk a little bit about the use of some of the wireless sensors that are available for structural health monitoring, but also we've got a new technology from another company, a Danish company called elasticsense. So I'm going to talk about that briefly as well. So as we all know, there's an awful lot of different sensors on the market. There's been a lot of ways of making measurements over the years, hardwired and wireless, and certainly there's a lot more interest in wireless these days, and for obvious reasons. The obvious cost benefit of a wireless system is much easier and faster installation, and of course you have a benefit in terms of costing of your cabling as well. These can be substantial. The labour cost alone can be significant, so there's obvious advantages for a wireless solution if it's usable in a particular application. Really, at the moment, there's two real basic systems that are being used, which is the traditional 2.4 gigahertz radio-based systems. There's also Wi-Fi based systems on the market now. Some of you, I'm sure, have heard of LoRaWAN, which is definitely an upcoming concept in terms of radio system. I think we're not getting the interest in LoRa-based systems as much because they very much rely on an existing network of transmitters and receivers. Whereas, as we can all appreciate, there's a lot of infrastructure out in the field, bridges, etc., which is miles away from anywhere. So you can't necessarily utilize a LoRa-based system, and thereby the traditional 2.4 gigahertz radio systems are still widely adopted, where you have an opportunity to use a wireless system. Typical configuration of a system here is just sort of display. We've got a mix of accelerometers and inclinometers. We have gateways, so we could have these distributed across quite a large site. We have a connection to an Ethernet, a router. Now that could be a 3G, 4G LTE router. We take the data up into across the internet, back into a user's office. It could equally go up into a cloud-based system as well. So you've got two basic ways of using the systems. You can either use them with a local PC, so stream the data from the gateways via a cable straight into a local PC, or you can take them up over, as I say, over a conventional 3G, 4G network. And you could be anywhere, quite literally, in the world monitoring what's going on with that sort of configuration. So lots of flexibility, depends really what the end user wants to do. An obvious consideration for any use of any system like this is that you've got good network coverage and signal quality in the location, because unless you've got that, you are fundamentally wasting your time. You're not going to have any benefit of the 3G, 4G network. And very much the same thing applies to the range of the system in question as well. So the sensors themselves, obviously, are the heart of the actual system. With this particular range of products, we've got triaxial accelerometers, we've got single and biaxial inclinometers, we've got what I refer to as a general purpose interface module, and I'll talk about that a little bit more in a minute. We have temperature sensors offered, combined temperature and humidity, and infrared temperature. Not so much of interest to you guys, I don't think, the temperature sensors. Really, I think you are more of interest have more interest in the accelerometers, the inclinometers, and the interface modules, the process sensors. Mounting options, we have a flat base, so you could use double-sided tape to mount the product. We have screw type arrangements. We also have a magnet type arrangement. So where you have customers who are a little bit sensitive about you drilling into an item, you could bond the product down. You could also use the magnet mount if you prefer that instead. And the products are designed for external use. So the mixometers, the inclinometers, the temperature sensors are all IP67 rated. The process sensors are 65, and you'll probably see why in a minute. So the accelerometers, very specific sort of ranges really, more suited to structural health or low G applications. They're not designed for what I would class as general purpose vibration testing. So you've got we've got a number of two specific products in terms of the accelerometers. You have your lower G unit, the AX3D, which is suited for more general work, if I can say that, in terms of structural health. So you've got a 2G or a 10G range. You can set your sampling rates up to a maximum of a kilohertz, 16-bit A to D, internal data logger as well. And these modules also have vibration analysis functionality built into them. So you can actually create reports in terms of peak particle velocity, FFT as well. We also have the 3DS, which they refer to as the shock accelerometer, two specific products with adjustable ranges. Whether you really call that a shock accelerometer in the true sense of the word, certainly from my background, but certainly if you've got a vehicle going across a bridge and you're exceeding the 10G range of the standard product, it's a good option potentially. And again, you've got internal data logger. You've also got a functionality called smart shock detection mode as well. The inclinometers, a number of different products offered. You can see one is deliberately called high inc, so it's a higher accuracy product. 30 to 90 degree, well, 30 and 90 degree ranges in the standard product, and then 15 and 30 degrees in the higher accuracy product as well. Being inclinometers, sampling rate is lower, the frequency measurement range is lower as well, because you don't need that same bandwidth that you would have for vibration measurements. Now the process sensors are, as I mentioned earlier, I refer to these as the general purpose interface modules. These will allow you to connect conventional transducers to the signal conditioners so that you in effect generate a wireless network. What I would say about this product is that whereas the accelerometers and the inclinometers are designed to be very power efficient, you're relying ultimately on the power consumption of the sensor you connect to determine the battery life. So there are some issues with this product, and you may need to power them locally to get the ongoing generation, the ongoing operation out of the product. So we've got three models in these process sensors. We've got a voltage input specific, we've got a millivolt unit, which is where you use strain gauges, and you use a bridge completion network with these as well. And we also have a 4 to 20 milliamp current input as well. So they certainly give you flexibility, but you have to keep the power constraints in mind. Now we also have another range of products which I talked about, which is the WiLo or the Wi-Fi based products. These are preferred by some people, not everybody. The range is much more limited, as you would with any Wi-Fi network, although you can extend it through the use of Wi-Fi repeaters. Lower power consumption, so these do have better life, and you can actually take a solar panel straight into these units to extend their operating time as well. With the other products, you tend to have to use a more complex type of solar panel arrangement. With the Wi-Fi products, you're only limited to accelerometers, inclinometers, or a combo, which is a combined accelerometer and inclinometer. Data acquisition modes are a big deal for wireless sensors, because fundamentally your battery life is a function of how long you have your transmitter powered up at full power. So you have a number of different operating modes where you can configure the product to go to sleep, wake up periodically and make a measurement and go back to sleep again. Or you may want to stream data continuously. You may want to configure it to just wake up every so often. Or you may want to have a semi-sleep mode where you then wake it up on the basis of a threshold being exceeded that it's detecting, and then it goes back into this semi-sleep mode as well. So these will all determine the maximum life of the unit when it's operating. Smart shock detection mode, we haven't really got the time to go into that, but again, that's very much the same thing. You configure the product to be in a semi-sleep and then wake up. Data logging, you've got two options. You can either log data to the memory on board the product, or you can stream it straight out. Some of the products are available with much larger memories as an option, or as I say, you can stream it continuously straight to the PC. If the data link between the product, the accelerometer, for example, and the gateway is lost, the data is automatically stored in the unit's internal memory, and when that connection is established again, that data is transferred, so you don't lose it. It's all just a question of making sure that you've got sufficient capacity. So we've got a couple of installations here on bridges and pillars where we're using inclinometers to measure the tilt on the pillars as the construction work's taking place. And we've got a couple of accelerometers here being used to measure vibration on the structure as well. Traditional DAC systems, still very valid in a lot of different applications. The big problem, so to speak, with wireless systems is that they tend to use real-time clocks in every transducer, and those clocks in time drift. So if you wanted to make synchronized measurements, you can do so for a short period of time, but not on a longer term basis, unless you reset everything manually using the system. Line of sight is always an issue. It can be an issue, should I say, in some situations. So that would rule out the use of a wireless system. You may have specific sensors that you want to connect. They may not be compatible with the units that are on the market. If you wanted autonomous operation, and the system below there is a standalone data acquisition system, which is IP67 rated, that can just be left to its own devices. There's a panel on the side there. You don't need to take the PC out. You can wander up to the unit as it's sitting and measuring. You can connect that panel up. You don't have to take your PC out every time. So this is a new concept from a Danish company, elasticsense. These are hyperelastic strain gauges, for want of a better description. We are the agent for this product in Australia. We're quite excited about it. In isolation with one product on its own, I'm not quite so keen, but actually when you put two together, and I'll show you this little video, it really is quite an interesting concept. So compared to a conventional strain gauge, it's quite a nice, neat solution, waterproof, etc., etc. And we're just getting involved with these guys on this. And we've also got a wireless product that they're talking about as well. So it's looking quite interesting. So, shut that off. Has anybody got any questions?
Okay, thanks, Jeremy. So questions, comments from audience?
Jeremy, I guess the binary stuff is
Sorry, very rushed.
super high speed, or fairly high speed. Do you have any lower speed done on lower speed?
Right, thanks very much, everybody.
John, we were not hearing you properly there, I don't think.
Jeremy, I did have one question. The Bean Air equipment is all high-speed or relatively high-speed data acquisition. Do you have any sort of lower speed, lower cost sensors in that sort of wireless range? Or
not at the moment. Certainly, we're looking at new concepts all the time, and where we can introduce something, we are. The thing with the Bean Air system is it is a complete solution, and I suppose that is where there is an attraction for some customers who don't want to try and get into integration into their systems. The WiLo products are actually Internet of Things based, so they are designed to work with an MQTT broker. So you don't actually need any software. You can actually you can stream data to a particular location, or you can instigate changes in commands, changes in the settings of the product over the internet without actually needing to have any proprietary software. So at the moment, they're the closest thing we've got. As I say, we're always looking for lower cost solutions which have got lower sampling rates. And at the moment, we're tending to use some of our Almemo-based systems from a company called Alborn. They have Bluetooth connections, so we're using some of those for lower cost applications, and their sampling rates are, well, 1 Hertz, 10 Hertz maximum. So that's something we're doing with people at the moment. That's not a waterproof solution though, and that's the only issue I've got with that sort of product.
Thank you for your presentation.
Thank you.
Okay, thanks, Jeremy. Concern time, may I stop here? Thanks for all the great presentations, and also thanks for our audience discussions. The session now is closed. So I hand over to